remember, to find the slope of a curve, we use the derivative because one interpretation of the derivative is the slope if we're looking at a graph. Okay, the derivative is just a rate of change, and when we're looking at a graph, the slope is a rate of change of y with respect to x, which is what we call the slope. So we want to find, in this case, to find the slope, we want to find dy dx. Okay, you guys agree with that? So we're going to differentiate with respect to x to find the slope here. So the first term, x squared, derivative is 2x, and we differentiate x's with respect to x, that's dx dx, that drops out, right? Okay, now we're going to have to use the product rule for the xy here. So we have x times y. The derivative of the first is 1 times the second, which is y, plus the first, x, times the derivative of the second, 1 dy, that's not a y, dy dx. Everybody okay with the product rule there? Okay, minus the derivative of y squared. Okay, equals the derivative of 1, 0. Alright, now we have to collect the dy dx's on one side and move everything else to the other side. So I'm going to go ahead and factor at the same time. So on the left side we're going to have dy dx times x minus 2y. And on the right side we're going to have negative 2x minus y. Alright, and then getting dy dx by itself is just a matter of dividing by x minus 2y. So we get that. Okay, everybody okay with that derivative? So then, if we want to find the slope of the curve at the point 2, 3, what are we going to do? So we want to know what dy dx is at 2, 3. And we're just going to plug in 2 and 3 for x and y. So we're going to have negative 2 times 2 minus 3 over minus alright, so on top we get negative 7, on the bottom we get negative 4, so that's the same thing as 7/4, right? So we know the slope of the tangent line at this point is going to be 7/4. This is our slope here. We know the point, 2, 3. So what do I do to write the equation of that line then? Yeah, I would use point slope here. So we would have y minus 3 equals times and that's the way I would write the answer. Now, if they had it in slope-intercept form, you would get y equals 7/4 x minus, what would that be? 1/2? Yeah. Okay, so that's the equation of the tangent line. How about the normal line? Yeah, so we would use the same point, but we would use the opposite reciprocal slope. So the normal line would be y minus 3 equals what? X minus dose. And again, you could write it in slope-intercept form if you wanted, but I don't want to. I like it like this better. Actually, it's easier to graph this than it would be if we wrote it in slope-intercept form, because then we would have a fractional y-intercept and it would just be ugly. So this is actually easier to graph this way anyway. Any questions about this one?